Hi everyone, today you will be learning about similar triangles. So what are similar triangles? Similar triangles have the same shape, but not the same size. In order for triangles to be similar to each other, the corresponding sides must be in proportion, and the corresponding angles have to be congruent. So for the corresponding sides to be in proportion, we need to make sure we have the same scale factor ratio. So remember how we put one side over another? So you see these are AC and DF. I'm just taking an example here. So AC and DF are corresponding sides, right? And AB over DE are corresponding sides. BC and EF are corresponding sides too. So if we all set them equal to each other, the scale factor ratio should be 1/6. So you reduce the fractions and you get 1/6 as the common ratio, or otherwise the scale factor ratio. This tells you that the triangles are similar. Remember to always write scale factors in its simplest form. We need to make sure that all the sides have the same ratio in order for the triangles to be similar. All similar figures have this. So this applies not only to triangles, but also to other figures as well. So then there's this perimeter ratio. What's that? So we have a theorem. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. So you have to find the scale factor ratio of the sides and set it equal to the ratio of the perimeters. If you need the actual perimeter of a triangle, find the scale factor ratio and set it equal to the proportion of one known perimeter over the unknown perimeter. So if you know one perimeter of this figure, then you set it in proportion to the unknown perimeter, and that you set that equal to the scale factor ratio. Use the scale factor ratio or the side ratio. The side ratio is always equal to the perimeter ratio. Once everything's simplified. Now let's see how we prove triangles similar. Okay, so we have three similarity proofs. So we have the AA similarity, angle-angle similarity. At least two corresponding angles have the exact same angle measure. So we have we need at least two to be corresponding angles to have the exact same angle measure. And if we have that, then we can prove that triangles are similar. And then there's another one. So we have the triple S similarity, side-side-side similarity. All three corresponding pairs of side lengths have the same scale factor ratio. Sorry, I don't know why I spelled it SCF. Oh, whatever. Alright. So remember in proportion. So we have 3/6. And we have 3.5/7, and then 4.2 over y would be 8.4, right? Okay, so all of these have a scale factor ratio of 1/2. SAS similarity. Two pairs of corresponding sides have the same scale factor ratio. One pair of angles are congruent. So the one pair of angles are basically the included angles. And remember for congruency statements, we said the included angles for SAS congruency. Same here. But these two are similar. So they must have included angles. And included means between the two sides, two corresponding sides. So then two pairs of corresponding sides have the same scale factor ratio. Okay? Alright, now it's time for some examples. Okay, sorry. So, similar triangles, angle similarity. So, if you don't take a look at the third angle measures, you can obviously see that these two only have one angle measure in common. So we need to find out if there's another angle measure that's equal in common. So basically you have to solve for each third measure by adding up all the angles. So take a look here. So I said 81 plus 60 plus x, when I didn't know this, equals 180. 141 plus x equals 180. Subtract 141 from 180, and x will equal 39. Same here. I add these two up and make this an x plus x equals 180. 121 plus x equals 180. Subtract 121 from 180, and you get x equals 59. But do these two triangles have exactly two angles that are corresponding and have the exact same equal measure? No, because this one has 180. So let's see, 81, 81, 40, 60, and 39, 59. So there's only one angle that's congruent here. So I said ABC is not similar to DEF. Alright, so triple S similarity. Can we prove that triangle ABC is similar to DEF by side similarity? Okay. So basically I put the sides in proportion. So I first said, okay, so DF AC. So I said AC over DF. So that's 2 over 1, right? 2 over 1 equals 2. Now you have to see if all the corresponding side lengths have the same scale factor ratio. So all the sides have the same scale factor ratio. So then I said BC over EF. See this side over this side. Right? And what's 6 divided by 3? That's 2. It's 2. Okay? Then I took the last sides in proportion, and I got AB over DE. Okay? So I have 4 over 2. Oh, sorry. This thing. Okay. Hold on. This is supposed to be. This was supposed to be here. And then so AB over DE, right? So 4 over 2. That's equal to 2. So they all have the same scale factor ratio, if you see here. So I said yes, triangle ABC is similar to DEF, right? by SSS similarity. Triple S side side side. Okay, now we have the last one, and that's side angle side. Is triangle ABC similar